Hey, I'm Dave. Welcome to my shop. I'm Dave Plummer, retired operating systems engineer going back to the MS-DOS and Windows 95 days. And today, I'm streaming live right from my shop within the Visual Studio code editor. I'll be writing code in C++ for the ESP32 that's in turn connected to a set of 60 powerful full-color LEDs inside my grandfather's ancient glass Hemingway powerline insulators that you can see right above my head once I switch the view. Oop, let me switch the view. There we go. Much better. Right now I've got them all just drawing a solid blue color to make sure they're all working, and I've done that by implementing the very minimal overrides for the base effect in a class for my LED project. We'll get exposed to more of that as we go, but for now, all you need to know is that there's a base class called BeatEffectBase that has a virtual member called Draw. So you implement Draw, and then by calling members like setPixel, you can draw out to the LEDs. Our draw function is called by the base class repeatedly, and if we don't add a delay, it would draw several hundred frames per second. So all our draw function needs to do then is to fill the entire LED chain with blue and then delay a few milliseconds in order to share the CPU cores with other tasks. To prove it all works live, let's change the blue to purple and re-upload to the microcontroller. Here is the code in question. So as I'm writing code, I should say, I've got the code in front of me here and the insulators above. So as I build this code, it will then compile and upload via serial to the microcontroller, which is connected to the LEDs. So all I have to do here is, let's see, it says blue now. Let's change that to purple. And here's my delay. And by the way, delay is friendly. It does actually yield the processor. It doesn't just busy wait. Now, being live, I can't really speed up the compiles. The compile is actually pretty quick, but it's the link phase that takes a long time on these, it seems. And then, of course, you get to upload. Port 21. I remember when having 2 COM ports was a big deal. I don't even know why I would have 21. I mean, I've got a lot of USB devices that probably have serial interfaces, but still. Half done. And let's see, what do we get? 100%. Hey. Purple. Just like we wanted. Now, we probably want to do something more interesting. There is, if we look at BeatEffectBase, there's one other virtual member that we can look at here. And it is Handle Beat. I'm just going to copy that. And go back to where I was, which was here. Inside, I'm going to close this because we don't need this open. Simply implementing this virtual function will have the effect of, because I've derived from BeatEffectBase, every time the microphone in the microcontroller senses a beat in the music, which is, of course, there's a lot going on between a microphone and a beat in the music, but that's all in the base class, so we can worry about that later for now. For now, when it does happen, it will call us, and we can do whatever we want. So I think all we need to do is to pick a random LED, a random insulator, and assign it a color. Let's try that. Fill it with a color, and then every frame will fade everything out by a little bit, which will have the effect that we can draw periodically, and it'll be bright and then fade out. So let's try that. Now, setPixel, our draw function, doesn't need to do anything. It needs to call the base class, because the base class is the one that does the work of scanning the audio channel to look for beats and things, that sort of thing. But it doesn't have to do any drawing, because the base class's draw implementation we'll call Handle Beat. I'm going to check one thing, and I'll be right back. Lock the door so somebody doesn't come bursting in and say something outrageous. Let's see, where was I? Handle Beat, yes. So first, let's call the base class. We know it doesn't really do anything, but it's probably good practice. So, next thing, we're going to pick a random insulator. Now, num fans, because the first implementation I wrote for this was not for insulators, but actually for fans in a PC case, which also has concentric rings of LEDs. And so some of the nomenclature switches partway through from fans to insulators, and I've got to rationalize that yet. But They are largely synonymous. Within a fan or insulator, you then have rings, 0 to n rings, which would be the concentric rings. And you define how many rings you have, what size each step is, because they can be smaller. I have a set of Christmas trees that are crystal, and I'm going to put nested smaller and smaller LED rings inside them. And when I do that, I need to specify variable sized rings, which I will do. So that's some of the code you'll see for rings, fans, insulators. I believe we have fill ring. Can we do fill ring? Fill ring pixels, yes. What color should we do? We're going to do a random saturated color. How handy that that function exists, because I do it all the time, so why not? I, for the insulator. Which ring? Which can do ring 0, which is the outer ring, which is the only ring that we know that insulators have anyway, so. Is that really all I have to do? No, I have to also fade every beat, or every frame, I should say. So I can say fade strip to black by. Now I need an amount here. What I'm going to do, take the number of seconds that has elapsed since the last frame. I'm going to multiply that by a number that, oh, I'm going to have to put in a clause here to make sure it doesn't go too large if it's a big delay, but actually, does that even matter? Yeah, it's good practice. I'll do it later. So, delta time is the amount in seconds since the last frame. We simply multiply that by, let's say, 1500. How do I know? Because I've written code like this before, and I know that that constant happens to work about right. You probably could work it out and say that that is 1500 reductions. Yeah, it's different because you can call it different times. You could call fade strip to black with 10 times, and I don't know if that's the same as calling it 5 times with 20. I'd have to check. But I know 1500 times the time elapsed is about the rate at which we want it to fade out. And we can go 2000 or 1000 around that, see if it helps, if it doesn't work out as we would like it. What am I missing, though? Oh yeah, I need to make sure that I never go over 255. But what is this? Double? Let's make this a double. Well, let's see. Every frame, we're going to take whatever's currently on the strip, and we're just going to fade it down by a little bit. Now I got a warning here. What's that about? Expected a... yeah. I'll buy that. Who's your baby? What's your angle? I'll buy that. Handle beat. Calls the base, picks a random number between 0 and num fans, and fills that with a random saturated color. What could be simpler? Let's see. Let's see if it even compiles, let alone builds and uploads and links and does useful things. All right, it is uploaded. What have we got? Ah, I saw, there you go. Hey, I'm talking and it's doing stuff. Let's try music. Sorry, that's all you get, because I'm not going to jail over some copyright nonsense. I'm much too good looking to rot in prison. Actually, I don't even know what you can probably get away with. Fair use? I'm not commenting on it, so I have no idea. I'll just be fair to the author, which I'm sure if the author was here and I said, hey man, can I like play 10 seconds of your intro to, and they'd say, just for $4,000? Of course you can. Actually, I have no idea, but I'm not going to try and abuse it, and we'll see what the YouTube detection thing does, and it will let me know what I have to do. Like, stop doing that, or doesn't care. We'll find out. Anyway, back to my code. Now that I'm all worried about the YouTube music cops busting down my door. Oh, that's right, I locked it. So what if we wanted to make it fancy? Well, one thing we should do here is It's not a big problem, but one time out of every 5, it's going to relay. Yeah, see, it did several times there, but it's at least a different color. But it's nice if you can light a different insulator than the last one. So if we just kept track of what was the last insulator that we lit and try not to reuse that number, that's pretty trivial. You could also do a queue of 5. Yeah, that's all you need to do, queue of the number of insulators. And you make sure you're not in the last 4, I guess, but we don't need to get that fancy, I don't think, because I think just eliminating the last one will allow it to, worst case, jump back and forth between the 2 insulators, and that should look okay. Hopefully that's not giving anybody seizures. Well, obviously, you wouldn't be watching flashing LED videos if you had a seizure disorder, but let's see. Probably if I type, it goes off too. Oh yeah, why not? That's also configurable. So in the base class, you can tell it 2 things. How far the VU meter must swing in each direction to be considered a valid beat, and how long it has to have been since the last beat to be considered a valid beat. So those 2 criteria are really lenient in the base class by default, and then you can say, no, I don't want this reacting that quickly, or to that driveway monitor. Release the hounds. Let me see. So we'll put an integer member here. No, we'll keep it in the protected section, so that future generations of virtual classes can benefit from my genius. Last insulator. And I can start at -1. And you're thinking, Dave, don't you need to put that in a constructor? No. No, it's not 1997 anymore. And I think I'm using like C14 at most, and up to 21 or some much higher number now that I have no idea what's going on in the current versions of C++, but I'm a little more up to date. So. So in theory, this should come in. It doesn't need to set it to -1. It's preference. So, because you can see it in the debugger is why. But pick a random number, repeat. I'm leaving. It's UPS. Yeah, I'm all distracted from the thing too. And I think that should work. Let's try it. Ciao. If I played the guitar or something, I could just bust it out, and then during these little interludes of compilation, linking, uploading, I could rock. I can't play copyrighted music. Royalty-free music is generally not super awesome. Although I could put something in the background here, I guess. Smooth jazz. All right. I'm not seeing anything. Why is that? Oh, wait, I just did. Not much, though. What the heck? What did I break? What the heck? It was working so nicely. Start at -1, but pick a real value. Oh, it's the num LEDs. Yeah, that's a problem. That's the number of LEDs in the chain, which would be 60. And I'm drawing off into space, although it will throw away such draws. And Let's check the serial output. Maybe I even warn. Blah, blah, blah. Yep. Let's see here. I'll show you this in a second. Let's stop this output. So we can see the beats are occurring, and it's doing 50 frames per second of the audio. Here's what the VU meter is reading, so on and so forth, what the peaks are in the various bands. I've got a 5-band EQ or spectrum analyzer running in the background as well. Then here's a beat has occurred, what the ratio was at the beat, how long it was since the last beat. And then the fan, our code, went to try and call draw fan pixels with position 168, count 12, but there's only 60 LEDs, and the reason for that is because I was randomly picking fans up to the number of LEDs, which is a bug, a big bug. So, fortunately, easily fixed, which I just did, so let's upload it, and it should work much better. Surprisingly, this is a 32-core 3970X with 64 threads, and it is no faster at the actual build and not even upload, just the link and compile, than my laptop, and which is a Intel MacBook, and an M1 Mac that I have. Because the Mac version must be weirdly faster than the Windows version, because the M1 beats this even though it has 4 cores, or 8 cores if you count the low performance cores. Hey, there we go. I think I saw it repeat. I don't get it. That's why I don't code live, baby. And that's why you test. Once you finally have a number you're happy with, remember it as the last insulator. All right, we're uploading. That guitar idea sounded pretty good, and I don't even know the guitar. So yeah, I gotta figure out something to do during these little compilation interludes. If I could actually answer questions from chat, that would be a good time to do that. So that would be my plan for next time. Let's see, where are we at? Yeah, I'm not seeing any repeat. Oh, no, it can go back and forth. Yeah, I'm not seeing any oh, I thought I saw 2 in a row there. Bop, bop. Bop, bop. Am I making that sound myself? Oops. Yes. Well, maybe I'll watch it in slow motion. But I'll draw the line there on this one, and we'll come back and we'll add some cool features to it in the next one. So, in the meantime and in between time, hope to see you next time, right here in Dave's Garage. Now, pardon me while I fumble around on my desktop looking for the stop streaming button.